All right, first one say to use the definition, which is, which one are they wanting us to use? This one. But they use A instead of X, so just be aware. That's what they're using. For some reason, they change. So they have the limit definition as h approaches 0 of f of a plus h minus f of a over h to find the derivative of the function at the given value of a. Now, if you remember my shortcut last year, you're probably going to be really irritated that we're doing it the long way again, but that's what the section says to do, so that's what we're going to do. So 2 f of x is equal to x squared plus 4, and it's at the point a equals 1. So anywhere we see x, initially we're putting a plus h, so we're going to have the limit as h approaches 0 of, and instead of a, we're going to replace that with a 1, so it'll be 1 plus h squared plus 4 minus, and I'm going to block this off, so it's going to be 1 squared plus 4, so that's at a, all over h so this is the limit as h approaches 0, and actually I'm going to do this 1 plus h up here. Whoa, not that. That wasn't it. I'm going to do this over here to the side. So 1 plus h squared is what?
1 plus 2h plus h squared.
Yep. And then this 1 plus 4 is 5, and then it's being subtracted. So anyways, that's going to end up canceling out with everything. But so I'm going to go ahead and add the 4 to this. So that's going to be 5 plus 2h plus h squared minus 5 over h. So then 5's cancel. Then I can take an h out of that. So the limit as h approaches 0 of h times 2 plus h over h. Since my h's cancel, then I'm left with 2. So the derivative at that point is 2.
It's basically what class section. This part, right?
Yeah, kinda. This is just telling us now that it's a derivative. Do y'all want to see another one of the a plus h ones, or are we ready to go ahead and move down to the second definition? That's this one.
We can do that now.
Okay. All right. I mean, it's basically the same thing. It's just a matter of changing what you plug in. So this says to use the definition, limit is x approaches a, f of x minus f of a over x minus a. So 6 is f of x equals x squared plus 4, and a is equal to 1. Now, what do you notice about this problem?
It's the
It's
same.
the same?
It's the same problem. We're just doing it a different way.
Okay. So should we end up with the same answer? Or will we? Okay.
We should, but they're asking you to use the definition, so, you know, you can't just write down, oh, it's going to be equal to 2.
Yeah.
So, we are going to have basically just x squared plus 4, so the limit as x approaches 1. Because this, remember, is the limit as x approaches a. A is 1. Of, we copy it down exactly, x squared plus 4. Minus, then we put in a, so 1 squared plus 4, or, yeah, over x minus a, so x minus 1. So this is the limit as x approaches 1 of, let's see, that's going to be 5, 4 minus 5, so negative 1. So x squared minus 1 over x minus 1. But right now, what's the problem?
If you plug in x into the bottom of the piece.
Kind of.
Yep. I would have a problem plugging 1 into the bottom, so back to the top,
Because it's a difference of squares.
which I'm going to do right here really fast. So this is going to be x plus 1, x minus 1, over x minus 1. So that's going to cancel. The x minus 1's cancel. So then I have the limit as x approaches 1 of x plus 1, which is 2. Isn't it wild? And if you did my shortcut method, you'd get the same answer.
I forgot how to do that.
I know it's easy. I just forgot how to do it.
I just remember never using it.
The shortcut?
Yeah.
You always did the long way?
You didn't use a shortcut?
I would never remember how to do the long way, so I would.
Because I always felt like I needed to check my answer to the shortcut with the long way. So it just,
I didn't do the long way unless this is what we told me to do.
Nah. I'm like, I ain't doing the long way unless I have to.
Yeah.
I
Exactly.
did not feel confident in my answers doing the short way. Because I felt like I did.
It's fair
Did you do
enough.
it right when you checked it?
Well, we're about to do the short way. A different problem, though. Number 10, this says to find dy dx if y equals 7x. So on the left side, basically when we don't ever write this, but when we're taking the derivative, we're always technically taking it of both sides. Because what you do on one side, you have to do the other.
Yeah.
So the dy dx is coming from taking the derivative of y with respect to x, which when we get to implicit differentiation much later on, I think it's like chapter 4 or something, you'll understand why we write it this way. But anyway, so the left side is going to be dy dx. Then the right side, you can do the long way. Okay? But you don't have it at a point, so you just have to keep that in mind. So we have to use a different method. But anyways, but I know it's gonna be mind blowing. What exponent's up here?
X.
What exponent's up here?
Exponent.
1. Okay, so there's a little imaginary 1 here. So the shortcut method is that we take this and we put it out front and multiply it by whatever's in front. Okay? And then we subtract 1 off of the variable. So this is going to become 7, and that's it. Because it's x to the 1 minus 1, which would be x to the 0, which is
0, 1.
1. So it's just gone.
I knew the answer, but then 0 came out. Oh my god, that's not what I meant.
So let me modify this problem a little bit. Let's do it as if y is equal to 7x cubed, so that we can actually see
Yeah.
a little better what's happening. It's hard to see with the ones that are just 1, but I promise this will be your preferred method, especially as we go. You will not want to do the long way with some of the things that we do later. So 3 comes out front and gets multiplied by 7. Okay, so I'm going to have on this side, I have dy dx is equal to, so 3 times 7 is 21. And then this part becomes x to the 3 minus 1, which is going to be x squared. So we always take 1 off the exponent, okay? And then we, so you multiply the exponent by the front, and if it's just a 1, then we just basically throw it out front. And then we subtract 1 off the exponent to do that. Now, number 12, they just use a different notation, but same thing. So 12, find d dx of f of x if f of x is equal to 3x squared. So this notation is saying I'm taking the derivative of f of x with respect to x. So d dx of f of x is equal to, so I take this exponent and I put it out front and multiply it. So 2 times 3 is 6. And then I have x raised to the 2 minus 1, so that's just going to be to the 1, which is just x. So that one would be 6x. Trying to see what section they actually teach you all the rules of, just taking the derivative before I. Oh. All right, let's do a couple other things that aren't actually in the book yet for this section, but I just want you to know them before we get there in the future section. So if you had, let's say it told you to take dy dx if y is equal to 4. So the derivative of a number, okay, that has no variable with it is what? Do you remember?
No, it's
So, no, just the answer there? Maybe just the.
it's on the tip of my tongue.
So think about this. Technically speaking, there's an x here, but it's raised to the 0, right?
Yeah.
So if I take that exponent and I put it out front, 0 times 4 is 0, so it's going to be 0. And 0 times x then takes the x away, so it's just 0.
So the derivative of a whole number is always
Yep. A derivative of a number with no variable attached to it's always going to be 0. So then, how about dy dx if y is equal to pi?
Still 0.
Still 0 because pi is a what?
number.
Number. So dy dx is equal to,
I remember
0.
when you said last year that tripped up so many people.
yeah, specifically Melcher. It was like a 10-point question on a test. And there's no work to show with it, so
Yeah, there's no partial credit you can't really get.
it's supposed to be one of those gimme questions, like when you give an exponent test and you like put, something to the 0, so it would be equal to 1, and they're like 0, and I'm like, no!
No.
Like that was a gimme problem. All right, but then if we have, say, dy dx, if y is equal to 5x cubed plus 4x squared plus 3x minus 2, we just have to do each piece individually and then leave it combined together. So dy dx, so we're going to take this piece by piece because they're being added together. Okay, if other things were happening, we would have to do it differently, but we don't need to worry about that right now. So ignore the rest of this. 5x cubed, what would the derivative of that be with our shortcut method?
15x squared.
15x squared. So we put the 3 out front and multiply it, so that becomes 15. Subtract 1 from the exponent, so that becomes a 2. So that becomes 15x squared. Plus 4x squared. What would that one become?
8x.
8x, because you put the 2 out front. 2 times 4 is 8. Take 1 away from the top, so 8x. How about 3x?
3.
Just 3, because their exponent is 1. And then that would give you x to the 0, which is just 1. And then negative 2? 0, because it's a number, and so we just get rid of it. Okay, so that stuff isn't in this section. This section is not that hard. Well, I don't think that's hard, but it doesn't have any problems that are considered that hard to use that method. But I just kind of want you to see it before we get into the next section so that you kind of had a visual of it before. Okay. what is the next thing?
Is it the one-sided? Is it the one-sided derivative for the next thing? 'Cause I know that was the
Well, I'm looking at the next examples. It might be, but I don't know. I don't really know if there's actually one-sided. Well, there might be, but I think they do it all with pictures.
It's just like the same
Yeah, I
kind
don't
of
know.
formula technically.
I don't think we actually have a one-sided problem to do in
I
this
mean,
section.
that
I don't
problem's fine.
really understand, but it's fine. Sometimes I don't understand why they like have stuff that you're supposed to like do, but then they don't give you problems to. I don't.
Yeah.
It's whatever. Maybe there are problems and I just have to find them. I don't know. There might be 2 problems in here. I don't know. We'll look at those later though. All right, this one says to find the derivative of the function y equals, this is 18, y equals 2x squared minus 13x plus 5, and use it to find the equation of the line tangent to the curve at x equals 3.
Oh, is this kind of like combining what we did?
Mm-hmm. So we are going to do this via the long method, even though we could technically do it with the short method because it's technically the way this is supposed to be done. So we know the x value is 3, so we need to find y. So how would I find y right now if x is equal to 3? So that I have my point ready.
With 3 tangents,
Plug 3 in. So 2 times 3 squared minus 13 times 3 plus 5. So what does that give us?
It's gonna give us
Negative 16. All right, so now I have my point because eventually I'm going to be finding the tangent line at 3 and negative 16. But now I need to find the slope. So to do that, I'm going to be taking the limit as x approaches 3. So this is just going to be the f of x minus f of a over x minus a. So 2x squared minus 13x plus 5 minus, we've already found f of a. Okay, this is f of a right here, technically. So that's negative 16. So minus negative 16, so that's going to be plus 16 over x minus 3. Are we tracking? Okay. So then,
What?
what?
Wait, what? Where'd you get the 16? Plus wait.
So this is the formula that's f of x minus f of a over x minus a.
Okay.
But f of a was this value here.
Oh, okay.
Because instead they gave us x is equal to 3, but that's like our a value from,
Okay, so we found
the
our
formula.
A value and then you formed it. Okay.
yeah, we found that right here, which is going to give us our y point for later. So that's part of why we did it first too, is that way we don't have to do it within the problem. It was already done for us. But we could have taken like this that we did, and we could have actually written it here. But since we had already solved it, I didn't see a need to write it again.
Oh, okay, I see now. Just plugging it in.
So then the limit as x approaches 3 of 2x squared minus 13x plus 21 over x minus 3. So this is a time when I'm going to do something off to the side to not have to write the limit so many times. I need to factor this because right now if I plug in 3, what's wrong?
0 on bottom.
0.
0 on the bottom. So I need to factor. So I'm going to take this piece off to the side over here and factor. So factors of 2 and 21 that give you negative 13. Maybe I should say factors of 42.
I was thinking
Well,
24.
6 and 7,
I don't know
but-
why.
Hmm?
I said 6 and 7, but negative.
Yeah.
Yep.
6 and 7.
Negative 6 and negative 7.
I thought 2 times 21.
So 2x squared minus 6x minus 7x plus 21. So then factor by grouping. Or Ethan, if you do your slide method, that's fine too. Isn't this what you did that for?
Mhm.
Okay. I don't remember how to do it, but you can do that too. So 2x, x minus 3, negative 7, x minus 3. So this is going to be 2x minus 7 times x minus 3. So now I'll rewrite my limit. The limit as x approaches 3 of 2x minus 7 times x minus 3 over x minus 3. Now we can cancel the x minus 3's. So now if we plug in 3, we get what?
Get a whopping -1.
Negative 1. Woo! So this is our slope of the tangent line. So now, how would I actually find my tangent line?
You put in the points. You get the point slope form.
So what would that be?
We're gonna do y plus 16, because it's like minus.
Yep.
Plus 16 equals -1 times x minus 3. Then do the thing.
What's this thing?
Yeah, do the thing. Y equals negative x plus 3 minus 16. So y equals negative x minus 13. Now, if we wanted to find the normal, what would we do differently?
You have to find the perpendicular slope.
Which would be what for this case?
Which
1.
Yep, positive 1, and then we would do the same thing. But this one didn't ask for that. This one only asked for the tangent. The next problem asks for both.
Of course it does.
Yeah. So 20 says to find the lines that are tangent and normal to the curve at y equals the square root of, to the curve y equals the square root of x at x equals 4. So we want the tangent and the normal this time. So, same process, limit as x approaches 4. Of the square root of x, so it's f of x minus f of a. So if we plug in 4 for x up here, what do we get? 2. So that's going to be minus 2 over x minus a, so x minus 4. Now what's the problem?
The bottom would equal 0 and there's nothing to factor. It looks like.
Y'all aren't going to like me. You can factor the bottom.
Oh, you factor the bottom? How would you?
What is this?
That's a square root.
The square root of x.
Yeah.
So what is this compared to that?
That's the.
How do I get from here to here?
You
Ignore the numbers. Just how do you get from the square root of x to x?
square the
You
square
have to
root
square
Square the square root. So now I have a difference of squares.
Oh.
Wait, what?
Just let me write it, and then I'll let you, and then
So
you'll
the
see
bottom
it.
is the difference of squares, or the top is the difference of squares?
The bottom.
Okay.
Oh, you're so.
So square root of x minus 2 over, in parentheses, the square root of x plus 2 times the square root of x minus 2.
That's so like technical.
Annoying.
That's like the most technical thing ever. Like on a technicality.
You're going to be even more mad when you know the shortcut to find the derivative of the square root of x.
I will.
You'll be like, are you kidding me? So, let me reiterate what just happened. Okay? So normally when we have a difference of squares, it's like x squared minus 4, and that would be x plus 2x minus 2. Okay? But on the top, I had a square root. And I needed to be able to, I don't need to get rid of the square root per se, but I needed to be able to get rid of something on, like I needed to be able to cancel something because 4 is a problem. Okay? So the only way to do that is to basically think about it as, well, 2 squared is 4, okay, and x is the square root of x squared, okay? So I basically just split them, okay, and to make them a difference of squares. Now, I very rarely ever see this have to be done, okay? So, again, part of why I do this one for you, so that you see it. Because now what can happen?
You can
Cancel out.
cancel it.
So now I have the limit as x approaches 4 of 1 over the square root of x plus 2. And now if I plug in 4 for the square root of x, I get 1 over 4. So that's my slope now of my tangent. And just to go ahead and note, what would the slope of the normal be? Yep, -4. So our point that we're working with is 4 and 2. Okay, because we already did the square root of 4 is 2, which is what gives us that point. So now for the tangent, I've got y minus 2 is equal to 1/4 times x minus 4. So y equals 1/4 x plus 1 plus 2. Wait. No, I lied. It's minus 1. I was like, that didn't look right. 1/4 x plus 1. So this is my tangent. And then my normal line, I use the other slope, y minus 2 is equal to -4 times x minus 4. So y equals -4x plus 16 plus 2, or y equals -4x plus 18. And now, if you left it in point slope form, again, I would be totally fine with the tangent and normals be lefting? Wow.
Right.
Yep, it's Friday. Being left that way. There we go, words. All right, any questions on any of this? Feel okay about it for the moment? So if it specifies that you have to do it by a particular method, like using a definition, you have to do it that way or it would be wrong, okay? So even though it's tempting to probably do the shortcut method because you know what to do, don't do it when you're doing your homework unless it's the ones like I did the shortcut method on, because when you get to test or the quiz, you're going to be confused. So problems are 3, 5, 7, 11, and like 3 and 7 I think are this like the same problem solved 2 different ways, and 5 and 11 I think are the same way, maybe, possibly. No, 5 and 9 are probably the same. Wait. 3. Oh, I lied. I didn't give you the problems that are the same. Never mind. Scratch that. If you wanted to check, there are problems that are the same though. 11 is one of the ones you can use the shortcut thingy on. And then 17 and 19.